Good evening, all. Good evening. You are welcome to the tutorials with Eternity the Schoolboy. Today we'll take a look at physics, and today we enter a new topic: scalars and vectors. Scalars and vectors. In our last topic we did discuss physical quantities and measurements. And when we discussed the physical quantities, we talked about fundamental quantities and what? Derived quantities. Now, this is a system or a kind of categorization of what? Quantities, depending on whether they are on their own or whether they are derived from other quantities. Those ones are there. But this categorization now is based on whether they have magnitude alone or whether they have magnitude and what? Direction. By magnitude, we mean numerical value. Numerical value. Whether they have numerical value alone or whether they have both numerical value and what? Direction. So based on that, we categorize quantities into scalar quantities and what? Vector quantities. And scalar quantities, as I mentioned, are known as scalars, just scalars. While vector quantity are also known as just what? Vectors. Now, by my definition now, what are scalar quantities? Scalar quantities are those quantities that have only what? Magnitude or numerical value without a what? Direction. Scalar quantities are those quantities that have what? Only magnitude or numerical value without what? Direction. So from this now, can we say that a scalar quantity can be a vector, can be fundamental or derived? True or false? True or false? A scalar quantity can be fundamental or what? Derived. True or false? Good. A scalar quantity can be what? Fundamental. It can also be what? Derived. Now, can someone give? Okay, don't worry. By the time I list the scalar quantities, now we can now know whether we have the one that are. You tell me the one that are derived in it and the one that are what? Fundamental. Okay, now let's go. So, examples of scalar quantities are as follows. We have examples. We have length in bracket distance. Length in bracket distance is a scalar quantity. Mass is a scalar quantity. Volume, density, time, energy, temperature, speed, etc. These are examples of what? Scalar quantities. Now tell me, which among, based on what we did in our last topic, among these scalar quantities I called, which of them are derived and which of them are fundamental? Oh yeah. Derived one are what? Derived one are what? Derived one are what? Energy, density, speed, No, it's not true. Is that all? Is that all? Mass, derived quantity. Okay, which of them are fundamental? Length, mass, time, and what again? Temperature. Good. So that means we are prepared to face any question that come out from what? Fundamental and derived quantities. Thank you very much for that. Now let's continue. Now let me throw more. Let me explain this. If you have, let's assume if you have something like volume now, we know volume is a scalar quantity, right? If you have volume, let's say you can add volume like this, maybe two volumes like 3 cm cube of 4 meter cube, as case maybe. Let me use cm. 3 cm cube, 2 cm cube. These things are volumes, right? Different what? Volumes. And they are what? Scalar. You can just add them at face value, add them arithmetically as it is, and get what? 5 what? Cm cube. Because they are what? Scalar. But you don't try it in what? Vectors. You don't do it in what? Vectors. You can add scalar quantity like this, just add them like this and get your answer straight, or subtract. But vector quantity, you must consider their what? Direction. Are we together? But this has no direction. You can just add their what? Magnitude or the numerical value and get what you are doing, what you are looking for. But this is not so for what? Vector what? Quantity. I remember, let's talk about, for example now, in our last class, I talked about distance. That if you like, move like this, turn like this, and go like this. Maybe you move to this, 2 cm, go like this, 4 cm, jump, go like this, 20 cm, run to this place. You don't look like you are the distance. I will measure all those things you have been doing. Am I communicating? To give you your words, the distance is covered. But that it can't, because distance is a what? Is a scalar what? Quantity. But you can't do that in a vector quantity. You could start considering the direction. Am I communicating? You start considering the what? Direction. So that's why I said that we say that vector quantity, scalar quantity, they have no what? Direction. And if you want to add them, you can just add them arithmetically and get your answer without long thing. So that's one thing with what? Scalar what? Quantity. Now, what of vector quantity? What are these vector quantities? Vector quantities are what? They are quantities, either fundamental or derived, that have both what? Magnitude and what? Direction. That have both what? Magnitude and what? Direction. That have both what? Magnitude and what? Direction. Now, if you want to, okay, let me give examples of vector quantity. The same way we did it in the scalar quantity. After listing them, you tell me the ones that are what? Fundamentals, and the ones that are what? Derived. Examples of vector quantity are what? What and what? Displacement. We have displacement. We have displacement. We have velocity. We have velocity. We have velocity. We have acceleration. We have weight. We have force. We have momentum. Displacement, velocity, acceleration, weight, force, momentum. Electric field. Electric field. So which of them are derived, and which of them are fundamental? Derived are what and what? Are what? Derived. Fundamental uncle? Displacement and what again? Weight. Is weight fundamental or derived? Weight is derived. Weight is mg now. What is derived? Which one again? Or what of electric field? Is it the derived of fundamental? Electric field. Is it derived or fundamental? It has direction, right? Is it derived or fundamental? Fundamental. Why this is? Don't worry. A lot of things are. A lot of things are involved in it. By the time we move there, I'll throw more light on that, okay? So, it's just that the focus here is just the what? Direction, okay? Don't want to, but so what? I ask you. You're asking me back. Why don't you know it? A topic we did. What have you? Did you bother to research on it? We have done this topic, so I should ask you a question on the topic we have done. It's not true. I spent hours here talking about this topic. I should ask you a question. If you truly you research, if you study, I should ask you a question on the what I've taught you to know whether you actually done something extra in what I taught you. Not you asking me a question on what I taught you. No, it's wrong. So. Have you checked, have you bothered to look for the same, find out where electric field belong? That is a new angle dimension I want people to learn how to study. Until you start doing that thing, you are studying. If you have taught something, go home. Try to find out more quantities that are fundamental. That is the actual meaning of studying. On your own, even without being told. Find out on your own. Is it fundamental? You don't know. Explain why it's fundamental. Oh yeah, I'm listening. Okay, talk. Huh? You say what? There's no time. So I should do what? No. Don't try this again. Don't you ever try this you said now. Did you hear me? That's rude. Don't try it again. It's wrong. Okay? Don't. It's wrong. I dictate the direction of the class, not you. You don't sit down and tell your teacher that go. That's wrong of you. Huh? Did you hear me? Don't do it again. If you take the work out of my class, that's wrong. Very, very wrong. Okay? So what you should do is, okay, you put it down, then you go and start not telling me to explain that no time. That's wrong. It's very wrong. That's wrong. Don't try it again. Then if lecture is going on, you feel that you want to go, you can take excuse and go. You'll be allowed. That is another way to do it. If you feel that the time is over for you, you want to go, you can take excuse and go. Nobody will force you to sit down. Okay? That's a bad manner attitude to class. Okay? Yes. In as much as we play, we joke, but I don't lose discipline. Don't try it. It's a very wrong thing to do. To lose the discipline. That's very wrong. Okay? All right. So, find out where electric field belongs. Find out where it belongs. By Monday, you tell me where electric field belongs, whether it is fundamental. If at all there's anything like that, just find out. Tell me what you discover from your research. All right, let's. I think it's okay. Let me just conclude with what I want to say in vector. Then, at least by introducing vector, we will be able to talk about the concept of vectors, definition, and examples of vectors. That's what we have, and the illustration on what happens when you are adding vectors and From our next class, we'll now go straight to, please, as you're coming to class next time, please come with, if you have a sheet of paper, come with it, plain sheet. Then come with a mathematical set. But I want us to look into something. 2 ways to represent a vector. Okay? Vectors. We want to check what is it called? The graphical method. Am I complicating? We want to actually see if we can do it graphically. Let you listen. This should complete. Your math should complete. You should have the, what is it called, protractor. Right? Just get a complete mass set. So if we present it on a plane sheet, we measure the angle and see whether actually is true. Because we want to do it by analytical method and by graphical method. We do it analytically by solving by calculation using sine, cosine rule and all those things. Then we also use graphically. We represent it on graph and measure the angle and see whether we get the same thing. Okay? That's what we will do in our next class. Please, as you're coming, that should be next week, Saturday. Come with your math sets. I'm communicating so that we can practice that. So that's what we'll do. In our next class, we'll talk about how to represent vectors. Then we'll now go to addition, subtract, addition of vectors. We'll look at parallelogram and the triangular law. Even though I give it to you in assignment, I want you to read it first on your own and state it in your assignment. In our review on Monday, we'll just say one or two things about them. Everything you're given an assignment, go to your textbook, open it. You don't know how to read. What I noticed these days, that this generation don't want to read. You must sit down and do what? Read. That's what you must do. That's why I'm doing what I'm doing with you. So you learn how to sit down and do what? Read. So make sure you sit down, go to your textbook, answer that question, because as usual, you come out here and talk about it. I'll just be here to direct you, guide you as we did today. But that from tomorrow, as I say, we'll not waste time again. Just 1-2 minutes, you are done. If you don't finish under 2 minutes, then another person will come, or I'll just do the correction and we move on to the next one. So we don't waste time again. If you're able to finish within 2 minutes and get your answer correct, the gift is me that will determine the gift. It's my pocket that will determine the gift, not you. Is any gift I bring you manage it like that. If it's pen I bring you manage it like that. If it's RC, you manage it like that. Okay, I think we'll stop here for today. But we are done. Unlike what is it called? I wanted to say something. Unlike in scalar vector addition, you don't do it arithmetically as we do here. Okay, you consider the direction. But when we now do vector representation now, I will now throw more light. If you remember what we did in that first class, when I told you that if you move like this, distance is there, but displacement will just take the shortest route and dictate the direction the person is going. So with that, we'll stop here so that you can go home and do other things. All right, thank you very much, and God bless you.